we already finished the discussion of summation of in-phase sinusoidal waves. Now we will go to summation of out-of-phase sinusoidal waves. So when two or more sinusoidal voltages or current waves are out of phase but have the same frequency, they may be added to yield a sine wave of the same frequency. But here you will consider na the magnitude and the direction, kasi they are already out of phase. Means they are not in the same direction. So to determine the magnitude of the effective value of the resultant of two like frequency sinusoidal waves, the following equation may be used. So the resultant of the summation of two out of phase waves is equal to the square root of a plus b cosine theta squared plus b sine theta squared. So your A is the magnitude of your voltage or current. Also the B, magnitude of the other wave, voltage or current. Cosine theta, this theta is between the two sinusoidal waves. So here is the sample for out of phase waves. First we have this wave, the E1, the equation of the instantaneous voltage 1. This starts at 0 and 0 value here. So this is in phase with respect to the x-axis or the reference. Another wave is this one. This is case 2, out of phase, diba, lagging. So this wave naman is started at time is equal to 0 but have a value. Ito. So it is 90 degrees lagging from the reference. So ito yung theta dito. If we add these two waves, E1 and E2, by the way, this E1 has a maximum 1 here and this E2 has a EM2 maximum voltage here. If we add these two waves, the resultant wave will be like this one. Ito. E resultant. This one. And it will have a beta angle equal to 45 degrees. So, paano natin makukuha yung magnitude ng E resultant? So, ito yung equation ng resultant of the two waves. R is equal to square root of A plus B cosine theta square plus B sine theta square. For the angle beta naman, we can calculate cosine beta is equal to E1 plus E2 cosine theta divided by E resultant. So, E1 and E2 here are in RMS. Also, this A and B must be in RMS. Kung RMS yung ginamit nyo dito sa A and B, so RMS din yung lalabas na value dito. Kung ginamit nyo dito is E maximum, so E maximum resultant naman ang lalabas dito. So, dapat consistent kayo kung RMS dito, RMS lahat. Kung maximum. Also, this cosine beta, kung maximum yung ginamit mo dito na voltage, maximum yung lalabas. And also, in RMS, dapat RMS to, RMS. Okay? Maximum. So, we can calculate cosine beta. This one, equal to E1 plus E2 cosine theta all over E resultant. This E resultant here is this one, E resultant. So ER is equal to square root of A plus B cosine theta square plus B sine theta square. So may checking to kung tama tong angle dito. We can check this one using your calculator. Example, ang value ng E1 mo is 1 angle 0. Of course, it is angle 0 kasi it started at this point. Naka-in phase siya, kaya angle 0. Yung second wave naman, since it is at the negative, so it is equal to 1 angle negative 90. If we add this to 1 angle 0 plus 1 angle negative 90, you will end up getting square root of 2 angle negative 45. So, tama yung 45 dito. So, this is angle negative kasi it started here at the negative. Okay? So, kung dito sana yung resultant mo, it is positive 45. So, let's try to solve examples. Number 1. Two units connected in parallel are energized by an AC source. If the component currents are 12 and 16 amperes, respectively, and the corresponding sinusoidal waves are out of phase by 60 electrical degrees, calculate the RMS value of the total current. So we have RMS values here. Let's say I1 is equal to 12 and I2 is 16 respectively, and they are out of phase by 60 electrical degrees. Out of phase by 60 degrees. Calculate the RMS. So RMS, we will calculate the total current RMS. If we draw the sine wave of this one, it will look like this. So, yung isa may maximum or RMS na 12, yung isa is 16. So, this is your 12. Since hindi sinabi dito kung negative or positive yung isang angle, yung out of phase nila, we will consider positive na lang. So, this is your 12 amperes and the other one is 60, displaced by 60 degrees. So, eto yung isa. If we add these two waves, what will be its resultant? So, mas madaling isolve in terms of vectors. We will draw the vector diagram of these two waves. So, I1 will be the reference, in phase with the reference, 12 angle 0, and I2 will be equal to 16 angle. So, positive yung kinonsider natin. So, 16 angle, positive 60 degrees. This is our reference point, x-axis. Our I1, eto, angle 0. This is I1. I2, angle 60. Using parallelogram method, we will add these two vectors. So the sum, this length will be equal to this. And the other one will be eto. Lalagay natin dito. The resultant this is IR. Theta, 60 degrees. Ito siya. It is between I1 and I2. Ito yung theta. And your beta will be from the reference. So, this is your beta. We can solve the magnitude of IR, that is equal to the square root of A. What is our A? 12 plus B is 16 cosine of 60 square plus B 16 sine of 60 square. Magnitude IR will be equal to 24.33 degrees, 24.33 amperes, not degrees. So what will be the value of your beta? The angle from the reference to our resultant current. So cosine of beta will be equal to I1 plus I2. So this is in RMS. So naka-RMS din tong resultant natin. So cosine beta is I1 plus I2 cosine theta divided by resultant. 12 plus 16 cosine of 60 divided by 24.33. That is cosine beta equal to 0.82203. So, angle beta is equal to our cosine of 0.82203. Angle beta will now be equal to 34.711 degrees. So our final magnitude and direction will be IR is equal to 24.33 angle 34.711 degrees. So this is a long method. So long method to. We can calculate this one diretso using calculator. So you just type. So IR is equal to I1 plus I2 vectorially. So the symbol for the magnitude and direction geometrically is we put arrow para ma-indicate na kasama yung direction. Kasi pag I1 plus I2 lang, ito ay magnitude only, hindi na-include yung direction. So you can input in your calculator 12 angle 0 plus 16 angle 60. You will get the same answer, 24.33 angle 34.711 degrees. Let's try number 2. Two loads are connected in parallel to an AC source and take current of 10 amperes and 40 amperes respectively. If the sinusoidal waves of the component currents are out of phase by 30 electrical degrees, calculate the resultant current. So, this is the same procedure in number 1. Try muna natin yung short method. So, we have two currents, I1, let's say this is 10. I2 is 40 and they are out of phase by 30 electrical degrees. So, try naman natin yung lagging yung I2. Kanina, leading yung I2. Ngayon naman, try natin na lagging. So, negative 30, this is angle 0. If we add this two, RR will be equal to, you just input this one in your calculator, plus 40 angle negative 30. That will be equal to 48 0.916 angle negative 24.133 degrees ampere. So let's try the long method. We will draw the vectors. This is our reference x-axis and our I1 is 10 angle 0. So nandito yung 10 in phase with the reference angle 0. Our I2 lags by 30 degrees. So 40 siya, mas mahaba kesa dun sa I1. This is I2. I1 and they are displaced by 30 degrees negative. So if we add these two, there will be a resultant using parallelogram. So ito, tsaka yun. The resultant will be here. So what is the value of your IR and the angle beta? So IR is equal to the square root of A plus B equal to 48.916 amperes. Solving the beta, this one. So, by inspection, makikita natin dito na if we read the angle between our reference and the resultant, clockwise direction, beta must be negative. Kahit positive pa yung nakuha mong angle dito, kung i-read mo siya clockwise kasi nandito yung resultant mo, so negative pa rin. Magiging negative yung angle beta mo. Beta is equal to cosine, arc cosine of 10 plus 40 cosine negative 30 divided by 48.916, that is 24.132 degrees. Since it is read in clockwise, this is clockwise direction, our resultant will be equal to 48.916 angle negative 24.132. Kasi pag positive yung kinonsider mo dito na 24, so nasan yung positive 24? Nandito siya. So wrong na yun kasi ito yung pinag-add mo, I1 and I2. Ito yung positive 24. This is the negative. So dapat negative yung direction dito sa beta. So nandito yung vector mo na vector ng resultant mo. Okay? So this is the final answer. IR is equal to 48.916 angle negative 24.132 amperes.